Okay, let's continue chapter 10. Special probability distribution. Alright, so there are three main parts which we will cover. One is the binomial. A new one will be Poisson. This is something new that you haven't learned in school days. Binomial you have learned. And of course the final one is the normal, which is the infamous, oopsie, the bell curve. Alright, so for now we study binomial first. So let's begin. Okay, binomial distribution, one of the main characteristic it has that it is a discrete. It's not a continuous. Okay, there are two main parts that you need to understand. Firstly, it has only two outcomes. Normally, we noted it as success and failures. A normal system, okay? But I don't like the word success and failure because sometimes fail can mean success and success can mean fail. What are you talking about, sir? well, let's say it's this. There's a disease. Okay, there's a disease. Right now in Malaysia, it's influenza A, which is actually a common cold. Let's say there's a disease, and this disease is spreading to whole Malaysian. And let's say if you caught this disease, the chances for you to die is 0.8. Let's say. Let's say the question goes something like that. If you caught this, if you have this disease, and it says here the chances for you to die is 0.8. That means it's a very, very little disease. What it doesn't say is the chances for you to live is 0.2. Okay, the question just stated that. I'm repeating to you one more time. Okay, please give me your attention. If the question says if you got the disease, the chances to die is 0.8, find the probability for it to be successful. That means the successful, it means death. Alright? So that's why I don't like the word success and failure. Because sometimes the negative outcomes can be success. I prefer to use the word outcome 1 and outcome 2. I prefer this word more. Because sometimes in exams, fail can mean success, success can mean fail. So I don't like to use the word. Okay, secondly, since this is a discrete, I like to use this thing what I call a room technique. This is something that I create for myself. Okay? Let's give it a try first. Let's say if I say there's an n, the number of staff is 10. Let's say if I say the total staff is 10. And right now I'm saying that I want it to be px more than 4. I'll do it this way. I write down 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I make a room for each one of them. More than 4. Does it mean including 4? Not including 4, so it starts from 5. So 5 until 10. So it means here P 5 X 10. Then only I can see things clearer. This room technique is going to save your life if things are getting more and more complicated. So I make a room for each one of them. Okay, so let's begin. So you start, okay, the formula is something like this, I forgot to say. NCX, where PX, Q, N minus X. Where N is a total number. X is the thing that you want to find. P, outcome 1, Q, outcome 2. Okay, those are the formula. And I think I better get everything's out right now. Let's get all the formulas out in the way. The mean. Which is the expectation? Is NP. The variance is NPQ. Which I can also note it as this value, these symbols. Sometimes when the exam, the question asks, when they ask you to find the variance, so you just do this way. And you need to know as well, what happens when P plus Q, what will I get? 1, why? The total probability. Right, so let's get everything's, the rules in the way. Now let's try the questions. Now you're trying to throw a coin. So there are two outcomes, head and tail. And we toss it 3 times. Oops, see what happened? So find the probability of no head. And second one, exactly 2 head. Alright, so let's begin. If no head, what does it mean by toss 3 times here? Yeah, I don't want translation. In terms of formula, that's your n equals to 3. Alright, so looking back at the question, so no head, that means x equals to 0. That's what they want. Px equals to 0. So according to the formula of NCX, Px, Qn minus x, so n is 3, c, x is 0, p, in this case, head, a coin, so it's half, 0.5 is okay. 0, half, so 3 minus 0, 3. Now press that in your calculator, what do you get? 3C0 is 1, this is 1, this is 1 over 8. Is that the answer? Should be it. Or if you want to go decimal, 0.125. Same thing. Alright, so that's first one done. What about the second one? Exactly 2 heads. 2 heads. I miss the S. Same style. Px equals to 2. 3C2 0.5 or half. 2 0.5. 3 minus 2 1. Press that in your calculator. What do you get? 3/8, if I'm not mistaken. Or 0.375. Both of them are okay. Easy peasy? Easy peasy. Can we continue? Very easy. Okay, now, second example. Let's say they're saying that in one box, 20% of the bulbs are damaged. And a random sample of 10 bulbs. Sorry, I just changed my pen. I think this one is bigger than mine. I think it's bigger than mine. Maybe the same size. Okay, firstly they want exactly 3 bulbs damaged. So how do you solve this? You want to try first? Write down your formula. We compare our answers. Exactly 3 bulbs damage. So gonna be, what's my n? I'm just using this formula again. My n is n equals to 10. P equals to 20%, 1/5. Q, which they didn't say, 4/5. So simply 10C3 1/5 3 4/5 7. Exactly 3. I think I should write this one first. Px equals to 3. .2013. That means 7 years ago. 2020, 7 years ago. Now what about if they say all bulbs are good? What do you think of this? Why are you saying x equals to 0? Why don't we take x equals to 10? Because the one the P is for damage. Okay, we want everything to be good. So that means how many damage? So when I say all bulbs are good, so I can also translate that to no damage. So Px equals to 0. Understand? The probability is for damage. We want no damage. So 10C0, 1/5, 0, 4/5, 10. Am I too fast? 0.1074. Do you want to try by yourself? Try this too. Not more than 3. Try this too on your own. Then we compare our answers. Okay. So let's try continue. So not more than 3. How do you solve? Not more than 3. That means the maximum is 3. So you add how much? 1 plus 2 plus 3. Then you miss the 0. So that's why I like the room technique a bit. So not more than 3, maximum is 3. I don't have a way for you to memorize there, not more, less than, or how more. For me, it's better rather than memorize. It's better for you to understand the language. Not more than 3. Sometimes I just need to translate it, understand it. So 0, 1, 2, 3. This is what we need to calculate. Px equals to 0 plus Px equals to 1. Px equals to 2. And I believe you know how to calculate them by yourself. 10 C0, I just do 1, 0.2, sorry, too small. 1/5, right? 0, 4/5, 10, and so on. You will get yourself 0.8791. Okay? You get the same? Congratulations. Now D, at least 1 box are broken. At least 1 are damaged. How do we do this at least? At least 1 are damaged. Which one is it? One damage. Now I go left or I go right? I go right. When you say right, it looks like my left. So, so I'm going this way. Understand? So if I do it this way, I have to do Px equals to 1 plus Px equals to 2 plus Px equals to 3 plus until Px equals to 10. That's a lot of works. That's a lot. Yes, you are right. Basically, 1 minus Px equals to 0. Alright? People are thinking left, right. Okay, can you show your process again? Yeah, sorry, the answers, I forgot about it. The answer is supposed to be 0.8926. Good. Okay, let's move on. Now, let's say. I think I become crazier and crazier as the lecture goes by. I'm tired. You become your true self. Okay, a fair die. A fair die. What does this mean? Someone die. Die. Is it die, death? di, singular, dice, plural. Dadu in Malay language. A fair die is throw, roll 300 times. So this means what? N equals to 300. Very good. And we want to observe the number 6. Find the mean and standard deviation. How? What's the formula for mean? And P, very good if you memorize it. N is 300. P is 0.6. 1/6. 0.6 for number 6 is very high. So you get yourself 41.67. Okay, on your own, standard deviation. Can you find for me? Can you find for me this one on your own? I give you 10 seconds. 3, 2, 1. What's the formula? Hey, sorry. I read it wrongly. This one, the answer is 50. My bad. So, this one here. What's the formula just now? NPQ, right? Are you okay with this? Wrong. This is for variance, dear. Just a slight reminder for those who forget how to memorize them. Standard deviation and variance. You can either memorize standard deviation 2-letter words, so standard deviation squared, I got variance, or you want to memorize this way. You see the word variance? It's the square root of variance, give you standard deviation. There are two main ways on how to memorize. So NPQ 300, 1/6, 5/6. Square root the whole thing should give you 6.45. Okay? Very good. I think that's for exact.